All right, what up, guys? We're doing this pre-calc assignment, advanced factoring, where you have x to the power 5 and got to figure out how to factor it. So it does say start off by state the possible number of real zeros of each function. So the real zeros are always going to be either all odd numbers or all even numbers. So there could be 5 real zeros to this question. So the possible real zeros should start off the possible we could either have the 5 or 3 or a 1. It does have to have at least one real zero, and that's kind of guaranteed if you think about the end behavior for a graph like this. It kind of goes up and down. It's guaranteed to cross the x-axis at least one time. However, it could cross up to 5 times. It's possible for the graph to end up going up and down like this, where it crosses 1, 2, 3, 4, 5 different times, or it could cross 1 or 3. It is not possible for it to cross 4 times. I challenge you to do a version of the graph as to why it's not possible for it to cross 4 times. But the main reason why is because anytime you have an imaginary answer, they always come in conjugate pairs. We'll see that one in example number 2. However, to start this question off, what we want to do is we want to type it in and graph it up. So I've taken the time to type out all 4 of these already into the calculator. The very first one we've done will show up like this on the graph. If you'd like to see the entire thing, there is a way to do it. However, the most important thing here is that there is a bounce here at -1. There are no other obvious zeros. These two we'll talk about in a second, but the most important one is this -1 here, because if we notice that -1, it's going to make the rest of the question quicker. So what I'm saying is we can use our zero function on the calculator, so we can hit second trace. Number 2 is a 0. And once you've hit that second trace and the number 2 0 button, it asks you left bound question mark. If you notice, it says 0 here and -15 here. So the graph, the dot is not currently showing up because it's down below. It's kind of like actually where my finger is, where the graph would show up. But if you start moving your arrows left and right, eventually you'll start seeing a flashing dot. That flashing dot needs to go to the left of the 0 we're interested in. So over here, the 0 that we're interested in is right there, and it's to the left of it is -1. And if we move to the right of it, there it is, the positive and the left. Just do a guess and hit enter again. And the calculator says -0.999996 because the calculator is only doing a guess. It's using a method called Newton's method to approximate the answer. The actual answer is exactly -1. Furthermore, this root is a double root. So you have x is equal to -1 with an m of equal to 2. That means that multiplicity happens twice. We're going to start there before we do anything else with this -4 and that square root of 31. So we're going to go ahead and get that -1 up in the box, and we're going to go ahead and do the rest of the division really quick. So we end up with a 3, a 31, a 16, a -64, a -67, and a -15. And we're going to go ahead and do this synthetic division. Here we go. So the 3, -3. I really hope I don't make a mistake. This will be so sad if I end up making a mistake. We get -12, and then +12, and then -48, and then +48. And that's going to be a mistake, right? Because that has to be 0. It's not 48. That's my mistake. It's not 48. It is 52. So the mistake, I knew I made a mistake, by the way, because this didn't end up adding up to 0 in the end. So that's how you can catch your own work too. There, now I got 15 in the negative, which makes this a +15, makes it a 0. Perfect. But happens again. You got to do another one. So you got a -1, and you got to repeat that process for that synthetic division. So you're bringing that 3 down, multiplying, -3, adding up, 25, -25, -37, +37, -15, +15, 0. And now to finish the rest of this question, we have a couple of different options. So we know for sure that part of the factoring of this answer, like part of our final answer to this problem, which I suppose I will write in blue, our f of x is going to be x plus 1 quantity squared. However, we also know that this -4 plus rad 31 is an answer. So that means x plus 4 minus rad 31. Make sure you switch both those signs. Is going to be one of the solutions. And then the conjugate rule. Conjugate rule says for any polynomial function that has rational roots, non-rational answers, namely the irrational and complex ones, will also have a conjugate root. So the conjugate root says right there, the conjugate root being -4 minus the square root of 31. That is also guaranteed to be an answer. Whoops. So plus square root of 31 now, by the way, because these are both pluses. The conjugate way that I remembered is that old TikTok joke. And you know, never heard no such thing as two positive conjugates. Always one of them got to be negative. There's my version of it, of that terrible TikTok joke. Point is, we have all these, but if you notice right now, we only have x to the power of 4. We need one more answer. So to get to that very last answer, we do need to do either a bunch of synthetic division or a long division or a little bit of math know-how. So our little bit of math know-how will come into play here. I'm going to go ahead and do the synthetic division. I want to do the long division method. So to do the long division method, what I'm going to do is these two guys right here, I'm going to multiply them together. If you multiply those two together, you'll end up getting a long division that you can deal with. So you can do a long division on this part of the problem and get to the answer. But I'm trying to think. Maybe I don't want to do long division. I'm going to do it in the next problem anyways. I want to show you that math know-how. So the math know-how here is getting to the other 0. So let's do it. We're going to hit second calculate, 0. And it says left bound again, but now I'm going to find this one over here that's on the line. So I'm simply finding this one. It's -0.333. What I mean by that is that -0.333, if you have your math know-how, you should know that 1 divided by 3 is that 0.333. So another solution here is going to be, you know, x is equal to -1/3. And if x is equal to -1/3, I can multiply both sides by 3. Add 1 to both sides, and I get 3x plus 1 as a factor, which is going to bring us to the end of the problem. I think that's the fastest way to do this particular question. You're also able to do a longer version of it, and we're going to see a longer version of it when we get down to problem number 2 anyways, so let's hop to it. Question number 2, exactly the same first step. Graph it and see if you can get some easy answers. So I'm just going to go graph it. So I'm going to go ahead and unselect this one and select this one. I really hope I typed all these in right. I didn't actually check. Oh well, we're graphing it up, and we graph it up, and we get a beautiful nothing so far. Ooh. Oh! Still thinking, by the way. The calculator's taking its sweet time with this problem. So that's all that shows up for us. Not that useful. It's possible that there are larger answers because it goes all the way up to 65 here for the x value. So technically, there is another fancy rule that you can simply take the largest two numbers, divide their coefficients, the largest and the smallest, divide the two numbers, 82 divided by 3, and that'll be the and then add 1 to that, and that'll be the largest possible number. That's called Cauchy's rule. I'll write down Cauchy's rule. The largest intercept that you have to graph, intercept, is going to end up being 82 over 3 plus 1 in both the positive and negative direction, by the way. And the way I got that from is I did the largest thing divided by the smallest thing, and then adding 1 to it. Again, that is Cauchy's rule. Quite an advanced proof to be, by the way. So the largest possible answers are 28 and -28. That's where we're going to go for our window. You could have also simply guessed larger numbers. You don't really need, -29, sorry. You don't need to do that, though. So I'm going to regraph it with the -29 and +29. I forgot to tell you I changed the window. I hit the window and changed that. Man, this video is not the best. I apologize in advance. Taking its sweet time to graph it again. But it looks like it's giving us the same thing, unfortunately. So probably is only going to have just those two real solutions. And because it's just those two real solutions, quite a bit annoying. So we have x equal to 0 as our obvious answer. So x equals 0 as the obvious answer, because we can start our factoring off by making f of x equal to x and then multiplying by some more after that. So we can immediately rewrite this question with simply the 3, I'm not going to write f of x equal. Maybe like write an arrow going to, and it becomes 3x to the 5th plus 17x to the 4th plus 62x to the 3rd plus 82x squared plus 59x plus 65. And the reason I did that is because I had an x that took out of all of these. It is also useful to attempt at least to find that other value. So to find that other value, we're going to go ahead and hit second trace, and we're going to try to find it by hitting the 0 again. And we got to scroll to the left of that number. So -3 is certainly to the left of it. And to the right of it, we don't want to hit 0, but we want to get close to it. So -4.3, you can see down there where it is. And then you can just scroll one left to hit the guess, and you get -8787. So to figure out what, you don't get -1.6. So just like before, it is just like that 2/3 again, but with another -1. So we have, so -2/3, right? And then -1, like an additional -1. And if you do that, you'll get that -6.67. But if you simply convert that to a fraction, you get -5/3. So there's your little math know-how. If you don't have that math know-how, you'll still be able to do the question. It's just going to take you a little bit of extra time. However, it does mean that we have the positive 3x, wrong color there, 3x plus 5 as part of our answer. And we still have to write more of it. But to deal with this 3x plus 5, we're going to go ahead and do synthetic division to get this to be a smaller thing. So we're going to go ahead and get -5 over 3 in the box, and then we have 3, 17, 62, 82, 59, 65. 3 comes down. Here we go. And multiplying it up, you'll end up with -5, and then you get 22. And I'm definitely going to be using a calculator for the rest of this here. So 22 times -5 divided by 3, you end up with -110 over 3, adding that to 62, and you get 76 over 3. Multiply that by -5 over 3, and you get -380 over 9. You're adding that to 82. And you get 358 over 9. This is miserable. Holy moly. I almost feel like I made a mistake already. -5 over 3 is right. Oh, I did make a mistake. Man, obnoxious. This is 12 I added, which makes this number wrong. It's always a good thing to check these, by the way, guys. This is your proof that you need to be checking. So let's go back. So 12 times -5 divided by 3 means that this actually should be a -20, which makes this a 42. And then we're going to have 82. No, we're doing 42 there times the -5 divided by 3. We get -70. All these fractions are gone now, which is great. So that -70, this 42 is my correction. And the correction there is 12. Now we can go back to actually doing the question. -5 over 3 times 12. We've already gotten that. Got -20 last time. So it should be -20 yet again. Yeah, -20. And then that's going to be a total of 39, and I really hope that 39 times -5 divided by 3 is -65, and it sure is, and we get 0. Remember, though, that the rule for synthetic division with the dividing by 3 is we now need to divide all these by 3. So we're dividing by 3 to every single one of those, ends up with the results of 1 and 4 and 14 and 4 and 13. So we divide them all by 3, and we have the 1. Okay, so we have gotten through the first 2 zeros, and we got both. The first one was just because there was an x in all of them. We got the 3x plus 5 through a little bit of math know-how. If you didn't have that math know-how, you would still be able to get to this in the end. It would just take you some extra effort at the end of the problem. Let's not do that. So after that, though, we are able to use our conjugate rule, our x plus 2 minus 3i, and ain't no such thing as 2 positive conjugates. Always one of them gotta be negative. So we have the negative 3i there and the positive 3i there as our roots. But now we need to do synthetic division on those. Or the smarter version of the problem is the long division version. I'm going to go ahead and do the synthetic division for the first one, and we'll do the long division for the later one. Here we go. So we're going to go ahead and put into the box here the negative 2 plus 3i. The 1 comes down, and we're now multiplying, and we're going to be super careful. More careful than I was in that last one, because I really don't want to do this again. 4 minus 2 is 2 plus 3i. And now we are getting to the point where we have to do some extra multiplication. Someone in class asked me the question, can I do this on the calculator? And the answer is yes. Let's cheat and use our calculator. Let's not even think about it. Your calculator does need to be in the right mode. Hit the mode button and scroll down to a plus bi. It does need to be in the a plus bi mode in order for this to work. If it's not a plus bi mode, it will not work. If you want to do this by hand, by the way, I should show you how to do it by hand just once, and then I'll show you the calculator after that. So doing it by hand, we're multiplying negative 2 plus 3i, and multiplying by 2 plus 3i, and when you do that, you get negative 4, and out here we'd end up with negative 6i, and then 3 times 2 is positive 6i, and then 3 times 3 is 9i squared. Because of the I squared, remember that I squared, by definition, I squared is equal to negative 1. So we have negative 4, the minus 6i and the plus 6i cancel, negative 4 minus 9, which is negative 13, which means that this is what goes right there, is negative 13. Just to prove to you, though, that your calculator can do this, is once you have enabled that a plus bi mode, negative 2 plus 3i times 2 plus 3i, and sure enough, you get that same negative 13. So it does work. By the way, the I button is used down here. It is that blue one above the dot. All right, finishing this up, let's make this again as nice and neat as possible. We have the 1, again, negative 2 plus 3i, and 2 plus 3i. And this is a repeat of the previous ones. This also has to be negative 13, which is 0, which is what we wanted. Finishing this up, we also know that the conjugate rule there, we have a positive 1 and a negative 1. Please note the negative 2 stays the same. Let's finish this off. We end up with negative 2 minus 3i. It cancels out completely, and you end up getting 0. So this is 0, and that's a 1. And that is negative 2 minus 3i, which is also a 0. That's our remainder, that's our constant, that's our x squared. We went with x squared plus 1. But we need to factor this one. To factor this one, we have to remember a last minute rule. Our last minute rule is anything of the form a squared plus b squared will factor into a minus bi times a plus bi. In this case, a and b are both a is x and b is 1. So this one is going to factor into x minus I times x plus I. By the way, if you wanted to figure out another thinking behind that, why that's true, if you have x squared plus 1 is equal to 0, subtract 1 on both sides, and then x is plus or minus the square root of negative 1, or plus or minus I, like we have written. So our very final answer, we're almost done, all the way up here, x times 3x plus 5 times this whole thing, multiplied by, and I'm running out of room on the page, this is times here, times x minus I times x plus I. Holy moly, what a question. And we got 2 more. Let's do it. Let's see if we can do this one even faster, though. So we're going to try to pick up the pace. Same exact idea, though. So we're going to start off by graphing it. So again, all I'm doing is going into my calculator, graphing it up, setting the window back to normal. To get the window back to normal, we hit zoom and then the number 6 for standard. And the calculator is thinking, oh, we have a nice, beautiful 2 answers, 3 answers that are super duper nice. And actually, that's going to mean that the rest of the question is really, really easy. This one might be a freebie. Ooh, I really hope it's a freebie. Let's see, second 0. And again, we're scrolling to the left until we see that dot. Oh, we're seeing it. We need to get to the left of this 0 over here, though, with the -4. I hope it shows up soon. It's gone. It's like a vertical line almost. Kind of a bummer. Whatever. We'll go to -5. There's our -5. And we need to get to the right of -4. So -3 is good. And then guess. And I should be exactly -4. Yeah, so -4 is one of our answers. Perfect. So we have x is equal to -4. And I really hope these are perfect answers and not square root answers. We'll find out. So left bound here. So we're scrolling. We're already on the left of it. Negative good enough. And then scrolling to the right of it. It showed up with that. Come on, be exactly -1. It's a square root answer, guys. That is not exactly -1, which means the other one's a square root answer. Dang it, I was excited that was going to be an easy problem. It's not. We can at least get this to start, though. We can at least begin it. So now we can start off by saying f of x is equal to x plus 4. We also know our conjugate rule. We have x plus 1 minus I and x plus 1 plus I. There's our conjugate rule. And now we can do our synthetic division, starting with this -4, because that's going to be the easiest part of the question. So 4, 24, 35, 2, -50, -40. We got the 4 coming down. So here we go. -4 times 4 is -16. 24 and 16. -16 is 8. -4 and 8 is -32. 35 minus 32 is 3. -4 times 3, -12. 2 and -12, -10. -10. -4 is 40, and that gives you -10 here. -4 and -10 is 40 again. You get 0. Perfect. Now we can start doing our synthetic division with the long, because the other ones are square root answers, unfortunately, which we will have to solve for at the end using our quadratic formula. So we have -1 plus I. That was given to us in the question. 4 coming down, and this is the part where we have to start being very careful. And we get -4 plus 4i. Adding those up, we get 4 plus 4i, and we are now cheating and using our calculator. It is not cheating. I don't know why I said that. It is completely okay to use your calculator. Do not think it's cheating. This is a difficult course. Don't make it more difficult by avoiding the calculator. 4 times I, and you end up getting exactly -8. Which means that we have -5 times that is +5 minus 5i, which is going to be -5 minus 5i. And yet again, we need to multiply, but that had better be +10. We can just double check it. So it's -5 minus 5i. -5 minus 5i. Yep. And we do get +10, sure enough. Get you 0, and then you repeat it one more time, and now you have it with the conjugate root. So same -1 in front, and then the I comes down. 4 is still there in front. And all the I should cancel out here. So we got -4 minus 4i. Ooh, everything cancels out, even easier. Finishing up, and we end up with 4. Well, this is your remainder, your constant, your x squared, and you get 4x squared minus 5 as that last remaining part of the factor. But now we can just solve that equal to 0 and solve it really quick. So you get 4x squared is equal to 5, which means that x squared is equal to 5 over 4. Take the square root of both sides. You get x is equal to plus or minus the square root of 5 divided by 2, which is pretty much what our factor is. But we want to make sure our factor, it doesn't have any fractions in it. So we're going to go ahead and turn that into the better version of the factor, which is 2x is equal to plus or minus that rad 5. We're just going to start with a positive one and then subtract just like that. Finally, we're done. 2x minus rad 5, 2x plus rad 5. Woo! One more question, guys. Here we go. Question number 4. Same exact thing. Start with a graph. I really hope there's some easy ones in this one. Please, please be nice to me, computer. I did not make these problems up. A computer did. Okay, so we typed it in. We have it going. Our graph is moving. Do 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 do. Oh, that's not perfect. Ooh, that one is though. Please give me more. I want to cry. All right. So we have the largest over the smallest. 56 over 2 is 28. Add 1, 29 again. Interesting. So let's just double check, make sure. Maybe the universe will be nice to me and it will show me some more answers. I don't have super high hopes. Yeah, it's not going to show me anything else, is it? All right, well, let's go ahead and... oh, by the way, if you want to make this so it actually shows up a little bit prettier, so we obviously don't need this negative 29 and 29. We can make it much smaller. So if you want this to show up prettier, change it to negative 3 to 3, and then change your y values to be much larger. Change it like 1,000. It'll probably show up a lot prettier. Look at that. Look at this beautiful line now. Easy enough. So we can calculate it. Unfortunately, one of these zeros is not going to be perfect. The one over here on the left. I really like this pink color, by the way. It doesn't show up as nicely on the camera. It shows up pretty nice kind of in person. Yeah, you can't see it as well, but it's really a really cool color. I've never seen it before on the calculator. Anyways, we have now found the zero by doing our calculator left and right buttons, and we get negative 1.87. So that is some nasty fraction that I don't know about. Yeah, I don't know what fraction that's going to be, or well, if it's a rational, it's an irrational number. It's supposed to have divided by 2, 28. No. I don't know. Maybe this other one's not even irrational. Maybe it's all irrational, and this is just really sad times and make me want to cry kind of situation. It might be. So let's find out. We'll go ahead and hit second calculate 0. Dude, this question is like one of those that you need additional math know-how. I might actually just give up. That'd be really sad. Find out. Oh no. I don't know. Alright, this is a typo. But don't worry about that. It is not. Oh, so it's 1.87 and negative 1.87, so it's going to be some kind of pretty answer in the end. Okay. Either way, we can start with this 1 plus I business. So if we start with this 1 plus I and go for it, we can at least go from there and finish it up. So we'll start with this 1 plus I. I really actually wonder what I'm going to do. I'm thinking about it now, and I don't know if I even know the best option. I mean, there's got to be an option. I know some calculus choices, but I don't want us to be using calculus right now. We're in precalculus. All right, so 2 plus 2i, negative 2 plus 2i, and again, we are going to use our calculator to our benefit. Oh, you can't even see what I'm typing in. I'm doing 1 plus I, and I'm typing in the negative 2 plus 2i, and that gives you negative 4. It gives you a nice, beautiful 1. 1 plus I, and that's going to give you negative 1 plus I when you add them up. And then we got the conjugate pair. situation going on, which actually makes it nice and easy again. You get -2, and that's going to give you -28, and that will give you -28 minus 28i, which gives you 28 minus 28i and sure enough gives you exactly 56. So we did all that right. And now we need to do the other one, the negative conjugate. The 2 comes down, and here we go. So let's see, 2 comes down, and we end up with, oh man, I can't even speak right now. So I have 1 minus I, you end up with 2 minus 2i, add them up, ooh, you get 0. That's really nice. That'll be good. Which means 0 there, 1 there, 1 minus I, ooh, another 0. Really great. 0, -28, which is -28 plus 28i here, which is of course 0. And ooh, okay, I know what to do now. This is an interesting question. Holy moly! Here's our remainder. Here's our constant. Sorry, our x squared, our x cubed, and our x to the 4th. So this now becomes 2x to the 4th, and then plus x squared, and then minus 28 equals 0. And man, this is a quadratic formula question on steroids. So, wow, this is a tough one. I'm just going to go through it best that you can. I apologize for such a hard question. I will not put a question like this in the test, but maybe you got a mean college professor in the future who does something like this, makes you factor this. So we already started off with part of the answer. We have the 1 plus I, the 1 minus I, but there are the power 6 here, which means there are 6 answers. The other 4 answers come from this. This is what is called a quadratic form. So to have a quadratic form, the idea is if I make u equal to x squared, this becomes 2u squared plus u minus 28 equal to 0, which means I can now use my quadratic formula to figure out what my answer is to this one. So using our quadratic formula here, we're going to go ahead and say a is equal to 2, b is equal to 1, c is equal to -28. I actually wonder if this is factorable. Does anything multiply to -56 and add to 1? Ooh, it does. 8 and 7. So actually, I can just factor this. Skip the quadratic formula. If you want to do the quadratic formula, you can. So I'll let you do the quadratic formula. It's just u is equal to -b plus or minus, square root b squared minus 4ac all over 2a, which means u is equal to -1 plus or minus square root of 1 squared minus 4 times 2 times -28 all over 2a, 2 times 2. Anyways, you plug all into your calculator, you'll end up getting what the 2 values of u are. I guess I've already done it. You could factor this too, is what I'm trying to say. Yeah. It's factorable. But I've already done all this work for this. I might as well just finish. Finish where I started. Finish what I started. -1 plus, now we have these square roots of 1 minus 4 times 2 times -28. And that is divided by 4. If you plug all that into your calculator, you're going to get u is equal to 7 over 2 as one of your solutions. And -4 as your other solution. So you have those 2 solutions for what they are. By the way, you could have, again, factored this using some factor by grouping, and you would have ended up with 2u minus 7 multiplied by u plus 4. So you could have also done the factoring there to get to that equal to 0. I don't really care which one you do. You pick your favorite. Using your quadratic formula to get to u, but the answer wants x. U is equal to x squared. So that means that 7 over 2 is equal to x squared. And now we have one that is very, very similar to the previous question, where we can just take the square root of both sides of the equation here. And if you take square root of both sides, you'll end up with plus or minus the square root of 7 over the square root of 2 is equal to x. rewriting this, it is customary to rewrite it with a rational denominator, or in other words, a square root of 14 over 2 is equal to x. If you want to know how you do that, I simply rewrote the 2 on the bottom and multiply the top by the square root of 2, which becomes the factor 2x plus the square root of 14 and 2x minus the square root of 14. For the situation where negative 4 is equal to x squared, when you take the square root of both sides, you get the square root of negative 4, plus or minus square root of negative 4 is equal to x, which is plus or minus 2i, is equal to x, meaning that x minus 2i and x plus 2i are the factors. We are going to combine all of this information for the entire Dane question for a final answer. A factored form, f of x is equal to x minus 1 minus I times x minus 1 plus I times x minus 2i times x plus 2i times 2x plus the square root of 14 times 2x minus the square root of 14. What a disaster of a problem. Have a wonderful rest of your day, guys. Peace out.